Okay, so we're all seeing it, right? The AI revolution is happening on a massive scale. It's promising to change literally everything, from how we write code to how we create movies. But behind all the big headlines, there's a hidden battle being fought, a fight happening at the molecular level that could literally decide who wins the AI race.
So let me ask you, what do you think is the single most important component that's going to dictate the pace of all this? What's the real choke point? The one thing that will determine who leads the next era of computing?
Now, if your mind immediately jumped to the GPU, the silicon chip itself, well, you're not wrong, but you're only seeing part of the picture. The real secret, the key that's going to unlock the next level of AI performance, is something way less famous. But trust me, it's arguably even more critical. To really get why this matters, we have to look at the next wave of hardware. Let's take NVIDIA's upcoming Rubin platform as our case study. We're talking about a system designed to handle 1 million token context. To put that in perspective, that's like an AI reading and understanding a whole stack of novels all at once. This kind of leap puts a crazy amount of stress on the stuff that actually holds all the chips together.
And check out the design here. Rubin is ditching the cables. We're moving to an architecture where GPUs plug right into a massive central circuit board, what's called a midplane. Now, to push these insane amounts of data around at light speed, you just can't use the same old materials. The boards themselves have to be made of something totally new, something with almost perfect electrical properties. In the industry, they call this M9 grade material.
And that right there brings us to the hero of our story, a special kind of plastic, a high-performance polymer that's suddenly become this huge global strategic asset. This is the molecular key we've been talking about, the thing that unlocks the crazy speeds Rubin needs. And its name is polyphenylene oxide, or as we'll call it, PPO.
So what exactly is PPO? Well, at its core, it's a high-performance plastic. But what makes it so special, especially for these new AI servers, are its dielectric properties. Fancy term, I know, but all it really means is that it's an incredible insulator. It lets those super high-speed electrical signals just fly through the circuit board without messing with them, without slowing them down.
Here's a simple way to think about it. Imagine the old standard circuit board material is a bumpy country road. Sure, you can drive on it, but try to go at Formula 1 speeds, you're going to lose a ton of energy, you'll lose control, and the signal basically crashes. That's signal loss. Now PPO is like a perfectly paved, super smooth German Autobahn. It's built for insane speeds with almost zero signal loss. For what AI needs to do, you don't have a choice. You absolutely need that superhighway.
Okay, let's get into the numbers, because this is where it gets really wild. Just look at that column for dissipation factor, or DF. That's basically just a number that tells you how much of the signal's energy gets wasted and turns into heat. The standard stuff has a DF of 0.02. Now look at the bottom. The M9 grade material, the one made with that special PPO, needs a DF of 0.00005. That is a 40 times improvement in efficiency. This isn't just a small step up, folks. This is a monumental leap in material science.
So, the natural next question is, if this stuff is so incredibly important, who makes it? Who controls it? And this is where we shift from pure tech to high-stakes business strategy. It's not just about chemistry anymore. It's about a global battle for a critical resource. It's a game of molecular monopoly. And this chart, wow, this really tells the whole story. The market for this super high-grade PPO resin, the stuff you need for AI, is incredibly concentrated. You've got one company, the Saudi giant SABIC, as the undisputed king, holding almost 30% of the market. Then you have a couple of Japanese players, Asahi Kasei and Mitsubishi Chemical. When you see a market this concentrated, as an analyst, alarm bells start ringing. That kind of concentration means one thing, a massive supply chain risk. So how does SABIC keep this top spot? Well, they've built themselves one heck of a moat. It starts right down at the molecular level with patents on their specific chemical formulas, which are super hard to copy. Then they have these deep, integrated relationships with the big circuit board makers like Panasonic. And finally, they just have a massive global scale. You put all that together, and it makes them incredibly tough to challenge.
But you know how it goes. Every king has a challenger to the throne. And in this story, that challenger is a company called Dongcai Technology. They're basically the tip of the spear for China's huge strategic push for what they call domestic substitution. The goal is to build a completely self-reliant tech supply chain inside China. By mastering PPO, Dongcai isn't just making a new product, they're trying to give Chinese tech giants a homegrown alternative to SABIC.
Okay, time to switch back to our analyst hats and follow the money. Why is there suddenly this huge fight over what used to be a niche plastic? It's simple. While the overall market for PPO is pretty stable, kind of boring even, the very specific slice of it needed for AI is just exploding. We're talking about a parabolic growth curve here.
I mean, just look at this contrast. It is absolutely stark. The general PPO market, it's growing at a pretty standard 4% a year. But the M9 grade stuff for AI, it's projected to grow at almost 33% annually. That's not just growth, that is a full-blown gold rush, and it's all being fueled by this never-ending demand for more and more AI power.
Yeah, let's just pause on that number for a second. 32.8%. That's the compound annual growth rate. Do you know what that means? It means the demand for this super specialized, really hard-to-make material is set to double roughly every 2.5 years. So getting your hands on a steady supply of PPO, that's not just a small logistical detail anymore. It's a core strategic priority for absolutely everyone in the AI game.
But wait, the plot thickens, because PPO, as critical as it is, can't do the job alone. It's part of a system, and its real value is completely tied up in a supply chain that is, frankly, incredibly fragile and specialized.
To actually build one of these M9 grade boards, you need a perfect team of 3 materials working together. It's like a triad. First, you need the PPO resin we've been obsessed with. Second, you need this incredibly pure quartz fabric to give it strength, and guess what? That's also in short supply. And third, you need this ultra-low profile, super smooth copper foil to actually carry the electrical signal. Get any one of them wrong, and the whole thing fails.
And here is the absolute critical takeaway for today. A hiccup in the supply of any one of those 3 things, the resin, the fabric, or the foil, and the whole AI hardware production line just grinds to a halt. It literally doesn't matter if you can make 1 billion GPUs if you have nothing to connect them with. This creates a massive, industry-wide bottleneck, a single point of failure for the entire AI revolution.
So, when we think about the future of AI, a future that's getting more powerful by the day, we have to remember something really important. The foundation of all this, it's not just about clever code or fancy silicon. It's about a really complex dance between chemistry and material science. The race for AI dominance, it might not be one in a data center in Silicon Valley. It might be one in a chemical plant somewhere else in the world. And that leaves us with the big final question. Who is going to end up holding these molecular keys to our entire digital future?